Thank you. All right. So before we get started this morning, I just want to get an idea of what people are using to test. I assume most people in here are doing JavaScript. Is that right? So we're trying to, at least. Are people using Jasmine already? Anybody? A few people? Okay. So if you're already using Jasmine, this is an introductory level session, so you probably won't get much out of this one. This is an introduction to Jasmine. We're going to be talking about using spies, doing basic testing with Jasmine, also a little bit on using Jasmine in Node, as well as using Jasmine in the browser. So is anyone in here actually using Node? Any few folks? Oh, wow. Okay. That's cool. So what we're going to talk about, again, this is a basic session on Jasmine. It's mostly for people who are new to it. And in JavaScript in general, we're going to go over Jasmine basics, talking about mocks, spies, and other things like that. Some of the code examples I'll be running, you can pull off this JSBin. JSBin, if you haven't seen it, is a nice website where you can do some experimentation. So you can see I was running the test this morning to see how everything worked. But it's a nice way to share code and to follow along. And you can find the code examples at this URL. And I believe that the slides will be available within a few days, right, on the website, right? So you'll be able to have the slides and you'll be able to look at the code examples at this JSBin URL. Okay, so let's talk about testing in JavaScript. And so Jasmine can be used to test browser-based apps, right? This obvious, especially for the folks that are doing it. How many people are using Angular in here? Few people, right. So if you're using Angular, the default test framework is Jasmine, okay? You can also use other test frameworks in Angular, such as Mocha. Mocha's another test framework that is becoming very popular. So if you're currently using Jasmine, it's probably a good idea to have a look at Mocha. It's spelled M-O-C-H-A. And it's actually a test framework that we're looking to move to because Jasmine hasn't been updated in a while. I know version 2.0 came out recently, and they've changed a bunch of things, but a lot of the momentum, especially for people doing server-side JavaScript with Node, a lot of the momentum is going towards Mocha as a test framework. So you might be thinking, well, why are you presenting on Jasmine if you're looking to go to Mocha soon? Well, in effect, they're both very much the same. You write test as almost the same way. Just Mocha has a lot of extra features that you can add on using plugins that Jasmine doesn't support. But we'll talk about more of that if we have some time. All right, so a basic test in Jasmine looks something like this. You use something called describe, you give it a callback function, which is the test itself, and then from there, you set up expectations. You use the word expect to say, I expect this to be this, or to equal this, or to contain this, or something along those lines, okay? So actually, we'll look at a real-world example in a couple of minutes, but a lot of people think that testing in JavaScript is actually hard, and that's kind of the case. How many folks in here are Java developers? Right, so pretty much everybody, right? So what do we do testing with in the Java world? JUnit, right? So most people are used to the way JUnit works, and it's a very straightforward framework as well. And in the JavaScript world, there are a lot of options for testing. There's QUnit, JS Test Runner, and obviously Jasmine. They all take a slightly different approach to how you test in JavaScript. So for example, if you're looking for a JUnit equivalent in JavaScript, you want to use something like QUnit. But honestly, when we test in JavaScript, we don't usually test at the unit level. And the reason for that is we find it to be too cumbersome, right? So that's why there are a lot of people, like if you're using Angular, you test in Jasmine. The reason why you test in Jasmine, which is a BDD or behavior-driven development type framework rather than a unit test framework, is because we find that testing at a slightly higher level is something that works better in practice than testing at a very, very low level, such as using QUnit, i.e. a unit testing framework. Okay, so testing in JavaScript, it is hard for a number of reasons. I have those reasons on the board right now. One of the main reasons why testing in JavaScript is more difficult than testing in something like Java is because JavaScript is inherently an asynchronous type of platform, right? So when you make a network call, JavaScript doesn't block. It goes and fires the network call over here, and your main thread of execution keeps running. So you have to have the ability in your framework to be able to test those asynchronous type of things, right? Obviously, a user clicking on a button in your HTML or doing some kind of input, that is something that also happens asynchronously, right? Those are events that come in. So in a lot of ways, JavaScript, it has it's an event-driven type of environment, so your test framework has to support that. And obviously, Jasmine supports that and has good support for that. We'll see that in a few minutes, okay? The other reason is that when you're testing in JavaScript, you have a couple of different things that you're testing actually, right? When you're testing in Java code, you're just testing the code, right? In the JavaScript world, you have the JavaScript runtime and the JavaScript code itself, but you also have this thing on the other side, which is the DOM. That's essentially where the state of the user interface is kept. So you have to be able to test the DOM, and it's decoupled from the JavaScript. So even though you're writing your code in JavaScript over here, you have to reach over to the other side and grab stuff out of the DOM to test and make sure that it's valid, okay? The other reason that testing in JavaScript can be hard is there are a lot of browsers out there, right? Fortunately, nowadays, the browsers are very fast. And they're a little bit more standardized, right? So if you're in the unfortunate circumstance where you have to test for Internet Explorer, that's when things become more difficult, obviously. So, but for what we generally test against are modern browsers, so we don't really worry about the older browsers, but these test platforms support reaching in and looking at those types of tests. All right, so I want to make a quick distinction between unit testing and behavior-driven development. When we test in the Java world and we do unit testing, what we do is we write low-level tests that test very, very small things. We test a unit of code, right? That's the idea is you test down here, you test, we go for line coverage or code coverage across all the lines of code we've written. But what we're doing is we're writing small suites of tests to test small things. When we do Jasmine and we do BDD, we're actually testing at a higher level. So when you do TDD, you're testing against specifications, and the idea is that you write a test, you write some real code, you test it, and then you repeat, right? Everyone has done this, so you get the idea for that. When we do BDD, we're testing at a higher level, and we're doing more behavior-driven development. We say, this piece of code should do this, and these are the steps that this big block of code that we're testing should be doing. All right? So the way that I like to think about it is when I'm doing TDD in Java, it's essentially doing one test per method. Right? That's the kind of core level that I think about when I'm testing using something like JUnit. When we test using a BDD framework or doing behavior-driven development, we think of a test as something that is not a single method, but a group of related things or functionality in our application that we wish to test. All right, so with that, let's get into some basic Jasmine matchers, and we'll run some code. The way Jasmine works is, and these are some very simple tests as you can see, you have expectations within your Jasmine test, and you say, I expect true to be true, right? If that's not the case, then obviously we have a big problem, but you get the idea. The other nice thing is that what makes testing in JavaScript a little difficult is that it's difficult to do comparisons between objects and arrays. It's not something that's built into the JavaScript language. There's no way to compare two objects using base JavaScript or two arrays using base JavaScript. You have to have some kind of utility that allows you to do that. And fortunately, Jasmine has something, it's called toEqual, and what it does is it does a deep comparison of two objects or two arrays that you may have. Right? Nominally, you can't do that. So the difference between toEqual and toBe is that the toEqual essentially does a Well, let's actually go look at this in code, okay? So the to equal actually checks equivalence, and the to be is the same thing as using a triple equal. So it has to be of the same type, or if you're checking objects, they have to be the exact same object. Not a copy of the object, but the exact same one. All right, so if we have a look at this in code really quickly, let me see if I can fit all this on the screen. This is going to be tough, but we will try to fit all this on the screen, okay? So we have two arrays here, var A equals 1, 2, 3, and B equals 1, 2, 3. So what we can do is if we run the two equals here, you can see, well, run the test, and this passes, and that's because the to equal is actually doing a deep comparison. So if I flip back to the slide really quickly, again, you have to remember that to equal is actually checking equivalence. It's doing, like, if you will, a deep comparison of objects or arrays in JavaScript. Whereas a to be is using essentially a triple equal to see if they're the same thing. So if I come into this code and I comment this part back in, expect A to be A, this is obviously going to work because they're the same object. But if I say A equal to B and A to be B, then we're going to get a failure. Okay, so which one of these is failing? You can probably guess if I comment this one out. You'll see that it still works. So the to be is essentially checking for exactness, triple equals in JavaScript, whereas the to equal does a deep comparison. Okay, so this is very useful, obviously, for a number of reasons. That way you don't have to unwrap an object or unwrap an array and figure out what's going on. So if we came in here and we did something like var C equals, okay, so I'm just going to hammer out two objects really quickly. We'll say var D equals this. So what I've done here is I've created two object literals, C and D. They're essentially objects. Now if I go and run this, and I say, do we expect C to be equal to D? In this case, yes. So if I go run this, you'll see that we have a failing spec. Which one is it? Right, it's the second one. So if we take this one out and we go and run it, you'll see we get the result we intended, okay? So this is pretty straightforward, but it's important to understand what's going on underneath the hood in the difference between to equal and to be. All right, so a quick word on the test, the way that I'm running the test. What I'm doing here, what I just showed was Jasmine running in the web browser. So if I flip over to the browser, I'm just using JSBin here, but the important part is I have a script tag here at the top. You can see it's a little crowded there, but I'm essentially importing the JavaScript library, which goes, and once the library loads, it goes and fires up the JavaScript, and it runs the JavaScript in order from top to bottom. I have a couple of other things in here, namely jQuery, but we'll get to that in a few minutes. Okay. The other thing that we can do to run these tests is I just have a spec here running inside of a node environment. So if you're running a node, what you do is you create a spec folder, and inside that spec folder you have file name -spec, or file name with the spec in the file name itself, .js, and the Jasmine node plugin. Okay. All right, so the Jasmine Node plugin is something you have to install via NPM or the Node Package Manager, and you say Jasmine Node and the spec directory, and we'll actually go and run the spec. So we'll get to these specs in a few minutes or look at these tests in more detail, but you can see that there's no DOM in here. This is just straight testing JavaScript, and obviously Jasmine Node is meant to test command line JavaScript or server-side JavaScript. Okay, so but this is how we're running it. Again, the Jasmine Node is something that you have to install using NPM, and it's the default environment for testing using Jasmine in Node.js. All right. So we've already talked about these things. We'll go on to some more matching. Now, one of the interesting things about JavaScript is that truthiness and falsiness are actual real words when people talk about JavaScript, right? It's not just enough to say true or false, because there are lots of things in JavaScript that can be true and lots of things in JavaScript that can be false. And Jasmine reflects this in the fact that you have these specific methods that allow you to test for truthiness or falsiness. All right, so here's some examples of these. Obviously, we expect true to be truthy. We also expect a object to be truthy as well. So if we take this, some of this code right here, and I'm just going to plug this into here. All right, so if we actually look at this code, you can see that in JavaScript, a object is actually true, okay? Which may sound bizarre because, when we normally think of true or false, we think of 1 or 0, or true or false, not, hey, this object is true, right? It doesn't really make sense semantically, but that's how JavaScript is, so that's what we have to do. And there are all sorts of edge cases. For example, an empty string is false. Let's see what happens if we fill this empty string in. Do we still get a false here? Right, so you can see that the string hello is actually not false, it's true. So if I change this from being too falsy to being too truthy, you'll see that my spec passes now, okay? But anyways, the point here is that JavaScript is a little bit of a strange language when it comes to Booleans. Things are truthy and falsy, and the Jasmine supports being able to test those conditions with the to be truthy and the to be falsy constructs. Okay? All right, so we'll come back to some more examples in a minute. And obviously, sometimes you want to check that something is not what it should be. So we can also expect an array not to be an object and other things like that. So this is essentially using, you can essentially chain a not in between any of the operators. So for some of the operators that we had here, we could actually go in and say, well, hello is falsy, or sorry, the string hello is truthy, run this is going to fail, and if we wanted to, we could do something like this, and our spec will pass again. Obviously, you have to be careful as to how you construct the specific expectations, but you can also do things like this to help you write tests and to test for specific conditions within your code. All right, so let's go on, talk about a few other things. One of the other nice things about Jasmine, aside from being able to do truthy and falsy comparisons or expectations, you can also test to see if a object or an array contains something. Now, this is not something you can normally do in JavaScript out of the box, but Jasmine supports the ability to be able to look into any kind of data structure and see if it contains something. So if we go into here, I'm just going to copy this code into one of my test suites here. And we'll just do it down here. All right, so we expect, let me make this a little bigger. Okay, so we expect the array of this to contain 3. We expect hello New York City to contain that. Let's go run this. Let's make sure this runs. Okay, it still runs. So let's change this. Let's break it. All right, so obviously hello Stockholm, it does not contain NYC, so when we run this, we're going to get a failure. So if I go in and I change this to this, then we're going to get it working. So what do you think is going to happen if I do this? You can see one is all caps and one is not caps. Is this going to pass or is this going to fail? What do you think? Okay, so we have about 50-50. Is it going to pass or is it going to fail? But it actually does fail, right? Because obviously in JavaScript, strings are case sensitive. It essentially is a different string. So I know it's a little bit of a trick question, but it's important to know these little details when you work in JavaScript, right? So it's very similar to other languages in terms of strings being case sensitive. So here we have var speaker. You can see that this is an object, and I have an object array in this case. So I have an array of objects, and we're going to test to see if this array of objects contains this other array, or sorry, this other object called Pratik. And obviously this runs, I ran it already, but you get the idea. You have a lot of little things in Jasmine that allow you to test for very certain conditions without you having to write the code and unwrap objects and unwrap arrays to do comparisons or contains and other things like that. Okay? Let's go on to the next one really quickly. So the other thing in JavaScript that can be difficult to work with is this idea of something being undefined and being null, along with the kind of truthy and falsiness of things. Okay? So in this block of code here, Sometimes you want to check to see if something actually exists, if it's undefined or if it's null. So if we take this code, I'm going to put this in here, okay? And so obviously we expect the string hello to be defined. So I'm just going to run this really quickly, make sure it works. Oh, we have a failure. Okay, what's the failure here? The failure is that some random thing is not defined, okay, which is this guy right here. So you can see that I haven't defined it anywhere, but if I take this and simply do, let's clean up this code, a var something. All right, if we do this, do you think this will work now? Or do you think it will fail? Okay. It doesn't actually work here for some reason. All right, so let's say, let's set it equal to something and run it again. And you can see that it's still failing because, right, so it down here, what we got is we got this to pass now. So it's the something else that's undefined is failing here as well. So anyways, you get the idea with, let me see if I can clean this code up a little bit. And this is locked up on me for some reason. Okay, there we go. Okay, let's just comment this out for now. We'll come back to it in just a second. Okay, so if we go run this, we have a couple of other things that are failing here, right? But I don't want to go too much into detail on this, but you kind of get the idea for what you can do to test to see if something is defined, something is undefined, and this can be a useful construct when you're writing test cases. Okay, and along with undefined, you also sometimes need to check to see if something is null. And fortunately, Jasmine supports the to be null to test to see if something is actually null versus undefined. Okay? So the other thing in JavaScript that can be a little problematic is using numbers. So floating point numbers sometimes don't have great precision, and you need to test for that. But even before you get to there, you have to test to see if things are numbers or not a number, right? So in this case, when we look at this test, you see expect 5 to not be not a number, but then when you divide 0 by 0, we expect that to obviously get an n or not a number. So let's just take this test case really quickly and go run it inside of our test runner. Okay, so if we go run this, you'll see that we get the result we want, because if we try to print this out, you'll see what the result is. Console.log 0/0. Okay, I'm going to go run this, and let me open up the console first. Let's go run this now, and you can see at the command line we actually indeed get a NaN for this specific block where we're expecting 0 divided by 0 to be not a number. Okay, and similarly, if we try to parse an int from this string right here. So if we try to do parse int against a string, obviously a string can't be parsed into an integer, right? That doesn't work. So you see when we run this, we get not a number as well. And what happens in other languages when you try to convert a string into a number? You get an exception. Right? JavaScript doesn't do that. What it does, it says, yeah, I don't know why you tried to convert this string to a number, but whatever. I'll just say that it's not a number and keep going. Right? Not very helpful sometimes, but that's what you have to deal with. So you have to test for these kinds of things in your code. And fortunately, Jasmine supports the ability to be able to test for things not being numbers. All right. Along with that, instead of having to write conditionals like if X is greater than Y or whatever, Jasmine supports the ability to just test for greater than or less than. Okay. What's also interesting is, and you don't really see this in other languages, but you can also test to see if something is close to another number. Right. So we'll take this test case right here. Let's get rid of this console. We don't need it anymore. Okay, but you can actually test to see if 12.34 is close to 12.3 within a specific radix. Okay, so if we go run this, you'll see that this test works. And let's go expand this radix a little bit. you'll see that we're failing now because it's not close enough, right? The radix is how many decimal points you want in exactness of that number. So if we come into here, and let's actually change this from 3 to 2, we'll run this, you see we still get a fail, but if I come into this, and let me just clean this up a little bit, let's make sure this works, okay? So you can see that we're still not close enough. So if let's do 12.31 here, 12.32 there, and we run this, you'll see that that now runs, okay? So the radix is essentially the number of decimal points you want to check for exactness within a number. The other interesting thing is that in JavaScript, you can also see if strings are greater than or less than something. So in the test case right above it, we expect A to be less than Z, right? That doesn't, I don't know how that really works. Conceptually, as humans, that works for us. So if we do this, this is obviously going to continue to run. If we do B to be less than B, this is going to fail now because that is essentially equivalent. And obviously, if we change B to be less than A, that's going to fail as well. Okay? So some basic comparisons. You can also do regular expression matching. So in this case, I'm not going to run this code because it's very simple, but you can expect hello STO to match using a specific regular expression to see if that is contained within that string. Okay? So one of the things that we do when we unit test in the Java world is we have a concept of something that can do a setup and a teardown to essentially get some data ready or to prepare the environment in some way, and then tear it down and get everything cleaned up for the next test. So we have the same concepts in Jasmine, but instead of having a setup or teardown method, what we have are functions such as before each and after each, where you can go and initialize some data, get it ready to run within the test case. And obviously, the before each will run after each iteration of a test, and the after each runs after each iteration of a test. All right. One of the things that's interesting is that in Jasmine, we don't need to just have a flat test suite. We can have hierarchical test suites, and that actually shows in the input. All right. So what do we mean by that? That means that we can describe there's some outer group of tests that we need to run, and then inside that we have an inner group of tests to run. So if we take this code and we go look at how this actually runs, so when we looked at the suite here, you can see that this is a flat test suite that I've created here, right? It only has one layer of suites inside of it. So if we take this code here and we go and put it into, I'm just going to put it on the outside. Right, so we have a couple of describes, basics, suite, etc. inside of it. So if we put this here at the end, you'll see that we have a describe. Let's move this over a little bit so it appears a little better on the screen. If we go run this and we look at the output, you can see that we're getting no output. That's great. Where's our output gone? Okay. That is weird. Maybe we need to just get rid of everything. All right, let's try this. Okay, that's really bizarre. Let's do this instead. Let's get rid of this. And we already have a couple of test suites in here. I'll just attach a test suite inside of another one. So we'll just take this suite right here. And we will nest this inside of this other suite, and we'll go have a look and see. Hopefully this runs properly. There we go. So I'm not sure why the previous example didn't work. It worked earlier, but you can see that we have a describe nested inside of another one, and when we go look at the output, you can see that it's indeed, it shows as being a nested suite inside of another suite, right? And the reason for going over this is that this can be useful to help organize your tests so that you don't have everything flat. You can have a nested suite so you can test some sub-functionality and give some organization to your testing. All right, so we've covered the basics. let's spend the rest of the time talking about some of the more advanced functionality in Jasmine, specifically spies and mocks. So a spy is basically something that you use to spy on a function invocation in various different types of ways. Okay, so if we have a look at a simple spy, this is the syntax for it. What you do is you say, spy on this thing with this specific method name or function name. And so the translator is an object, and I'm going to switch to this for a few minutes. Okay, so what we have is we have a couple of simple objects. We have a person object and a translator object. The person object has a say hello function that basically takes one argument and runs hello, or invokes the hello function. And we have our translator here, and you can see that it has the hello function, and when we want to invoke it, what we do is we say person.sayHello, and we pass in the translator, and that goes and invokes the .hello underneath it. But what we want to do is we want to spy on this thing, so what we do is use the spy on function in Jasmine to say, in this translator object that we have, we wish to go and spy on, here's the object that we want to spy on, and this is the specific function inside of that object that we want to spy on. Okay, so when we invoke person.sayHello, we can see that there are a couple of things we can do. We can ensure that a specific function is called inside of an object. In this case, what we're doing is we're saying we're expecting translator.hello to have been called. And Jasmine magically goes and adds tracking to that translator object, specifically in this case the translator object and the hello function inside of it, so that we can verify that it actually has been called. So if we go run this, okay, and I'm going to run this from Node. You can see that this is actually working. But let's go and actually break this, and let's not call person.sayHello. Right, so our test case is just spy on it. We're not going to call it this time, but we're going to have the expectation that translator.hello should have been called. So now if we go run this test case, you'll see that we'll get a failure. You can see we get an F here. It says we expected spy hello to have been called, but it wasn't called. Right, so we've gone and broken the test, and we've verified that we've tested for the fact that for some reason we expected the translator.hello to be called, but it was never called. Okay, and obviously if I put this back in and go rerun the test, you'll see that everything will be fine now, and we're getting green across the board. Okay? So, one of the things you can do additionally with the spies, you can also actually change the value that's supposed to be returned from the invocation of a function. Right? So this can be useful for doing mocks. So if you have a service, like let's say you have a user service that reaches out over the network and logs in a user. Well, you don't necessarily want to do that in your Jasmine test, to actually do a real login to a server. You may just want to mock that part out. So what you can do is you can spy on that user service, and when that login user function is invoked, you can just have it return a true and set up some data and other things like that. So let's have a look at that really quickly, get an idea of how that works. Right? So you can see that this is the basic syntax. You can say spy on translator hello, and instead of returning what it should return, just return this specific thing, in this case hi. Okay? So again, here's our translator. We're going to spy on it, specifically the hello function, but instead of returning hello, which is what our translator does normally, right? So here's where it returns hello. We're going to say instead of returning hello, let's just return hi. Okay, but let's double check that this actually works. So we checked up here that the translator.hello has been called, but let's also check to see if, I'm going to take a little bit more code here. Let's actually check to see that the result of that is actually something that works. Right? So let's just put a var in front of it so we don't create a global. Now if we go run this, this is going to fail because our translator is returning, by default, returns a hello. Okay, so we've written a test case that is meant to fail. Save this, we're going to go run it, and you can see we get a failure. It said expected undefined to equal hi. Okay, so if we go in and change this to hello, Let's make sure this works properly. Okay, we're still getting a failure. Let's take this down here, actually. All right. So this is what we want to do. Is we want to say go invoke this and return hi from it instead of returning hello. If we go run this, we can actually go look at the log, console.log result. Okay, so let's go run this, and you can see that there's our hi and hello that we got out of it. Okay. So essentially what we've done is we've mocked out a specific function call to return something else instead of actually doing what we expect it to do in this case. All right, so let's go on to our next topic on spies. The other thing we can do is a spy can be used to count the number of times something is called, right? This can be very useful when you're testing. Not only can you check to see if something has actually been invoked, but you can see has it been invoked 1 time or 5 times or 10 times, okay? The code for this is very simple. Right? You can see that we invoke the translator.hello here, and then we just go, and since we've attached a spy to that translator, we can do spy.callCount, and it will return us the number of times that thing has been called. So if we go into here, can count calls of spy. So you can see we're only invoking it once here. So let's actually go and break this test case and invoke it 3 times. Okay, and also let's actually see what that number is. So we can actually just reach directly into the spy here and say console.log, give me the call count, and we'll print this out. Actually, let's add a little thing to this so we get a better readout. Now if we go run this, you can see that here's my spy.call count was 3, and it says the person can count calls of spy, and we expected 3, but equals 1. Okay, so you can see that's because we ran this 3 times instead of just once. So if I take out those extra calls and I go rerun our test case, you'll see that we get success this time because we only invoked it once, that's what we expected. Or we can obviously come in here and say, let's see if we called it 3 times, and you can see our spy.callCount went to 3, but we told it to expect it to be 3, so we get a successful test case. All right. So let's move on to a little bit more about mocking. So one of the things you can do is we saw that we can directly change the return value when we invoke something, but what if we want to actually fake the entire object or the entire function that's being called instead of just setting what the value of the return should be? Okay, so what we can do with that is we use a spy and we do and call fake. Right, so if we go look at this in code, so we have our translator from up above here, right? This translator, it has a hello function, and all it does is return hello. But let's say we want to do something else. Okay? Let's say that instead of returning hello, we just want to return hi. All right? What we can do is we can say fake the call so that instead of using the built-in or the existing hello function, let's create a mock hello object here, which is a function in this case, and let's say we just want to replace that completely with something else. So when we run this, all right, we saw on the command line, this is from mock hello, and now if we go and run this, you'll see that all we're doing in this case is we're just going to print this out to verify that the new mock hello was called, right? There are obviously a bunch of different ways we could have done this, but for demonstration, we're just going to print out this is from mock hello, and we see that indeed that thing was run and not the other one. Let's actually verify this in a slightly more subtle way. Say in our translator, say this is from original translator. Okay. So unfortunately, this is going to print a couple of times because we have the test case running a few times, but you get the idea here. What's happening is we're actually taking the function, and we're doing a complete mock of it. We're just injecting another object. And again, this can be useful for something like when you have a user service.login. In your test case, you don't want actually to reach out over the network and hit a server and log you in, or log in a user. You may just want to put a surrogate object inside of there, a surrogate function that just mocks it out, sets up some data, sets up the username in your environment, and just inserts a mock rather than the real function. All right. So we're on the home stretch here. There are a few other things that we need to talk about quickly. And again, I spoke earlier about this, how JavaScript is fundamentally an asynchronous, event-driven programming environment. So we have to have some utilities to be able to test asynchronicity. Okay, so there are a couple of things that we can use in provided by Jasmine to do that, specifically runs and waits for. Okay, let's have a quick look at this. So runs is a construct that allows you to separate different blocks of code, test code that should be executed. And obviously waits is just something that causes your test to wait and for a set amount of time. So if we have a look at a couple of these. Okay, just want to make sure this test suite is still working. Okay, yep, it's still working. All right, so what we're going to do here is we're going to say, go run this function, but with the timeout of 250 milliseconds. So essentially what I'm doing here is I'm simulating like a network call, right? Network call, it fires off and it runs over here on the background, but for the purpose of this demonstration, I'm just having a set timeout that gets fired after 250 milliseconds. And specifically what I'm testing for is that this foo value, you can see from the syntax highlighting, the original value of foo is 0, and the timeout sets it to be the set timeout sets it to be 1, but that happens 250 milliseconds later. So what we do is we say, go run this block, and then go run this next block, and then we wait for a second, and then we check to see that foo equals 1. So what happens is we set up the timeout, fires 250 milliseconds in the future. Immediately after we have set the timeout to start, we go check to make sure that foo is equal to 0. We wait about a second, and then we check to make sure it's 1, i.e. that timeout has fired. So this is a way that you could test a network operation, for example, by simply waiting for a small amount of time. Okay, so if we go run this, you'll see that you probably noticed right here in the middle that the test paused for just a second, right? So if I take this out and we make a break, you'll see that the test runs instantly, right? Because it's not waiting for that second in the middle for that timeout to fire, and we get a test failure because we haven't waited long enough to test that timeout from firing, right? And again, the timeout is sort of like a way to simulate a network call. So if we put the waits back in, and let's bump the time down to 500 milliseconds, that should be enough time for us to wait, right? And you can see that we waited for 500 milliseconds. That gave the timer enough time to fire, set the foo to be equal to 1, and our test was passing in this case. Okay, so this is one technique you can use. There's actually a better way to actually wait for something to happen, okay? And that specific thing is called wait for. So what you do is you fire a function off, and you want to wait for that function to finish before you continue on your test case. And that's what the wait for is used for. I do want to make one more quick note here, that you might be wondering, why do I need this runs in here? Right? It seems like we should just be able to put the code in here and everything will be fine. But when you're using Jasmine, if you use waits like we have here, or wait for, which is what we're going to see in just a second, you have to have the runs keyword around blocks of code, because otherwise Jasmine doesn't know exactly what it should be running when you put a wait in. So if you, in the previous test you saw, like for example, this test right here, you can see we didn't use a runs. And that was because we didn't need to, since we didn't have a waits or a waits for. If you're using a waits or waits for, you need to have runs in that block of test code, because that helps Jasmine to know how to run that specific set of tests. Okay, but let's go talk about waits for quickly. So again, waits for is something that we would use when we want to test something like a network operation. Okay, so you can see what we're doing is we're going to say wait for this function to finish running. In this case, I'm just returning true. And this next parameter is a failure parameter. Okay, And this is how long we should wait for it. So you can actually set a timeout and say, hey, if this thing doesn't finish within 3 seconds, then this should be a failure. Okay, so if we go into here, and obviously this, we've already run this a bunch of times, but this obviously works. But we can go in and change a few things around. I don't really have any assertions in here, which are very useful. But you can see that in this case, this would fail after 3 seconds. Because what we expect from this waits for is the function to return a true. When I flip it to false and make it fail, you can see that as we can probably guess, let's put a little console.log in here to see exactly waiting for this to fail. All right, so I'm just going to put this console.log in here so we can see when this is running. All right, let's go run this. And you can see that it seems like it just keeps calling it because it's failing. It's because we're returning a false instead of a true. So if I flip that back to true, and then I go run it again, you can see that it printed it out, but because it returned true, it didn't keep retrying it. It returned instantly. Okay. So one last thing I want to talk about. So far we've just been doing pure JavaScript, and we haven't been working in the DOM at all, right? And that's probably what you're interested in. So that's the final thing I want to talk about this morning, and that is that when you're using Jasmine, you can use pretty much any library you want, right? But for the test that we're going to run in just a second here, we're actually going to use jQuery, right? So, and there's actually a really nice library called Jasmine-jQuery that you can go, if you're already using jQuery, you can go get Jasmine jQuery, and it gives you a bunch of additional matchers, you know, to contains and other things like that, that are helpful when testing markup. So, but testing with any library is super simple. You basically use the same constructs and you just insert in the specific syntax for the library to test something inside of it. So if we go into our web browser test here really quickly, you'll see here at the end, let me just show the HTML. It's nothing fancy. Again, this is meant to be a simple demonstration. I have a div tag here called test1, and it contains hello. All right, so then if we go down into our test case, you can see I have the jQuery $sign here, and if we scroll to the top, you can see that I'm using jQuery in this specific application. But what we're saying is we expect the test1 thing with test1 ID, the text of that, again, this is just standard jQuery. And let's make this a little bit bigger. Okay, this is just standard jQuery right here, this part. Right, so I'm just saying in jQuery, use jQuery, go get the test1 div, and give me the text out of it. Right, and we expect that to be hello, so we're going to break that to say hi. Right, obviously that's not going to work. If we look at the test case, you'll see it's expected hello to be hi. Okay, that makes sense. So now if we go and put that back in and unbreak it, our test suite is going to pass. All right, so we have a few minutes for some questions. I'll be happy to entertain some questions until our time is up. So any questions, any comments? So everyone needs more coffee, is that right?
Is there tools to integrate the Jasmine test to the build cycle? Like,
Yeah. Okay, so the question was is there a way to integrate the running of the Jasmine tests into some kind of continuous integration tool like Jenkins or Hudson? The short answer is yes. You can find, you can integrate Jasmine into Hudson or Jenkins or whatever. Or virtually every build tool supports being able to plug in Jasmine to run your test suite as part of, you know, your overall application build. Okay. Yes, sir.
Hey. Yeah. Sorry, I know it might be a little bit off topic, but do you have any experience with the Angular seed yet?
Okay, yeah.
And if you do you have any suggestions on how you could do effective testing of controllers?
Right. Okay, so the question was specifically around how do you use Jasmine to test Angular. I don't actually use Angular very much, so I won't be able to answer that question. But the short answer is I don't know. So I don't use Angular. So, okay. More questions? No. Okay, thank you for coming. Hope you enjoy the rest of the day.